โอเคนะครับคราวที่แล้วนะครับ we have um, discussed about how to evaluate the truth value นะครับ there are two. I think I've gave you a preview of how you can evaluate the truth value, right? So given a propositional statement or a proposition, um, you should be able to evaluate or to find or to determine what's the truth value of that proposition. Okay, so there are two main uh, approach that you can use. Okay, the first one is to use the truth value, which we discussed a little bit last time. The second one is to use what we call a logical equivalence. Okay, so let me give you a brief review of the truth table. Okay, so when you are given a proposition, okay, you if you want to find the truth value, you can use the truth table. Okay, so truth table is basically you just list all possible truth values of that proposition by combining one when combining all the possible um, input of each atomic proposition that you have in your proposition, right? So for example, in this table, they want to find the truth value of this statement. I should put a bracket onto it. So they want to find the truth values of P or Q imply negation of P and Q, right? So as I said last time, the first thing you should do is you should determine how many rows you should have in your truth table, right? To determine that how many numbers in your how many rows in your table, you should find how many atomic proposition in your proposition, right? So in this one, you can see that you have two atomic proposition, that is P and Q, which means that you will have 2 to the power of number of proposition or atomic proposition, which is 2. So you will have 4 rows, right? So that's why this table only have 4 rows. So and I gave you a little bit of example. If you have 3 atomic position, so you will have 8 rows of in your truth table, right? And that's so basically once you write all possible truth values of each atomic proposition, you can just combine um, find the truth value for each expression. Okay, building up to the final one, you might separate the final proposition that you want to find, separate them into smaller proposition, and then combine them to make the final proposition that you want to find the true value of. Okay. The second one that we can use to find the truth values of a proposition is to use logical equivalence. Okay. Logical equivalence basically mean that if you have two propositions, say P and Q, P and Q are logically equivalent when they have identical truth values. Okay, so basically we say that P and Q is logically equivalent. We say P and this symbol, uh, the equivalent symbol, okay, similar to the equal symbol. Okay, so P is logically equivalent to Q, so we write P is logically equivalent to Q. Okay, so this one will give you two things. You can know that you will immediately know that the truth values of both sides of the equivalent symbol are equal or are the same basically. So you can use this. Okay, you can also use the truth table to determine the logical equivalence of something. For example, if you want to check if P's negation of P and Q is logically equivalent to negation of P or negation of Q. Okay, you can do that by building this truth table. Okay, basically you just have to have one column that is in the term of on the left hand side, and the other column is on the right hand side. As you can see that if all the rows have the same truth values for these two columns, that is in the equivalent equation, you say that they are logically equivalent. So in this example, you can see that they have the same logical truth values. Okay. But for this example, if you do, if you want, for example 4, if you want to check if negation of P and Q is logically equivalent to negation of P and negation of Q. Okay, you can build the truth table showing the truth values of these two expressions. So you can have PQ, negation of P, negation of Q, P and Q, negation of P and Q, negation of P and negation of Q, right? So the column that we are interested in are these two columns because it shows the truth values of negation of P and Q and negation of P and Q, negation of Q, sorry. So once we compare these, the truth table, the truth values of these two expressions, you can see that the first row is the same, but the second and the third are not the same. So this shows that these two expressions or these two propositions are not logically equivalent. That's why I say yeah, not logically equivalent. Okay. And these are some of the logically equivalents that you can use. Okay, so let's say that you have, take a look at some of these. So if you have a proposition P and true, okay, you will always have P, because anything and with true will always have the same proposition. P or false, also you get P, right? P and false, you get false. P or true, you get true. P and P, you get P, right? Same thing. P or P, you get P. Negation of P, you get P, right? That is the double negation law, right? P and Q, you can swap the position between P and Q. That's called commutative law. Basically, you can swap. This is the same as, oh, I think I missed this one. This is the same as P or Q is logically equivalent to Q or P, right? I think I missed one of the line there. Similarly, if you have P and Q and then N R, these will be logically equivalent to P and in the bracket Q and R. Okay, this is called associative laws. P or Q or R is logically equivalent to P or in the bracket Q or R. Okay, so you can choose to do and with the front pair and then do the and for the other proposition, or you can do put the bracket at the back, to do the back pair. Okay. You also have this distributive law where you have and outside and then you have or inside the bracket. You can distribute it inside. You can have, if you have P and Q or R, you have a logical equivalent to P and Q or P and R, basically. And you have P or Q and R. You can have P or Q and P or R. Okay. The last, or not the last one, I think we have a few more, but this, the last in this table here, this is called De Morgan's law, which is very important, right? So if you have a negation outside and inside you have P and Q, you can distribute the negation. You can get the, instead of negation of P and Q, you get negation of P or negation of Q. Okay, negation of P or Q, you get negation of P and negation of Q. Okay. Well, you probably know most of these already, but just want to make sure that I go through with it again. Okay, as always, you don't have to remember all these as in your exam or when you need to use it, you can open your book and then check the table anytime you want. Okay. A few more that is quite useful is that when you have P or negation of P, you always get true. And you have P and negation of P, you get false. Okay. This is very important. If you have P imply Q, you get negation of P or Q. Okay. And if you have P if and only if Q, you get P if P then Q and if Q then P. Okay. So as I said earlier, that we have this table. Okay, we can use this logically equivalence table to check whether or not two propositions are logically equivalent. Okay, so what you do is suppose that the question is to check if negation of P or negation of Q and P and Q is logically equivalent to negation of P and negation of Q. Okay, the first thing you can do is actually the alternative ways to use truth table. Actually, that's one of the way that you can do it, or you can use the logical equivalence, which basically mean that you try to convert the proposition from the left hand side or the right hand side. It's up to you, and then make it to be the same as if you pick the left. We're trying to convert it using these logically equivalent rules and change it into the right hand side. Okay. In this case, I'm gonna change. I'm gonna convert this one into that on the right hand side one. Negation of P and negation of P. So basically, I just write down the left hand side first, and I just change it, trying to make it to the right hand side negation of P and negation of Q. So you have negation of P and or negation of P and Q. So this one, you can actually distribute negation outside, inside. So you get negation of P, you change or into N, and then you get negation of P and Q, right? And just make sure that I write something down, that the reason that I can change from the left hand side here to the right side here is this the reason, the law that I took from the table here. Okay. So next one would be to maybe distribute these negation again. So I have the N inside, right? So I distribute it inside, I get negation of P, and N convert to or, and Q convert to negation of Q, right? So that one is also De Morgan's law. It's the first one because inside is the or. And then I use again the, well, not again, but I use the double negation because I have double negation here. So double negation, just basically you can cancel out. So you get everything the same, but negation of P and negation of P converted to P. Okay, so I just write double negation law. The next one would be to distribute negation of P outside into this P or negation of Q. So I get negation of P and P or negation P and negation of Q, right? This is just write in them. These from this to this is the distributive law. Last one that well, not the last one, the second last one is negation of P and P is basically false, right? We have this one, and negation of P and negation of Q, we just leave it there because it's almost there. It's almost what we want. So we have false or negation of P and negation of Q, and we know that false and or with anything basically is this one. Oh, where is it? Oh, this one. P or F or false, you get P, right? So this one false or this thing behind it, you just cancel false, and then you get negation of P and negation of Q. So which is basically the same thing that we want to find. Yeah. So now we just show that this one can be converted, this negation of P or negation of P and Q can be converted to this negation of P and Q, negation of Q, okay, using the logical equivalence. Okay, that's how you do it. So there are two ways that you can show that the two propositions are logically equivalent. Use truth table or use this logically equivalence. The next one is about tautology. Okay, tautology is the proposition that is always true. Okay, tautology. So the opposite of the tautology is a contradiction. Okay, a contradiction is a statement that is always false. Okay, or is the negation of the tautology, which is false. Okay, some of the tautology is, for example, P or negation of P, right? That is always true. That's always true. P imply P. That is always true. P if and only if P and P. Okay, it's very so I'm not gonna go through all this, but all these is basically tautology. Okay, maybe look at the last one. The second last one is P and P if P then Q imply Q. Okay, so this is our tautology as well. Okay, last one will be P imply Q and negation Q imply P. This is also a tautology. This is quite important. So that's why it has its own name, one is ponent and one is tollens. But as always, you don't have to remember this. You can always come back and check. Basically, well, these actually, if you want to check if these are actually is tautology, you can use again truth table. Just write truth table of this expression, and you can see that the truth value will always be true, right? All these, or you can use logically equivalent. Two things, okay. Okay. Okay, two more slides. The second one that is very important is the conditional statement. Okay. Why I say important? Because this is the most used in our everyday life. Like if P, then Q. If we have a reason to do something, then it results in doing something. That's what we call a conditional statement. Okay. So a conditional statement is written as if P then Q, like this. Okay. We usually call this P a reason, or sometimes we call it a hypothesis. Okay, and we can call Q, okay, a result, or sometimes we call it a conclusion. Okay, a conclusion. Okay. If P then Q is very special because it's always true except when P is true and Q is false. Okay, it's always true except when P is true, Q is false. Okay. There are some other propositions that related to the P then Q. The first one is called contrapositive. Okay, it's basically it is negation of Q implying negation of P. Okay, the next one is converse, which is just basically just Q imply P, right? Just swap the position of P and Q. The last one is the inverse, which is basically you put the negation on P and Q. So you have negation of P imply negation of Q. Okay. Contrapositive, converse, and inverse. Okay. All these three, only the contrapositive is logically equivalent to the conditional statement. Okay. Only the contrapositive is logically equivalent statement. Okay. So which means that they will only the contrapositive of the conditional statement is have the same truth value as the conditional statement. Okay, so they are logically equivalent. Other statement, converse and inverse, are not logically equivalent. And the last one, well, we already seen this, right? If P then Q is logically equivalent to negation of P or Q. Okay. The next one is of the operation, logically operators, is the biconditional. Okay, biconditional written as P, and then you have the arrow with the both side pointing like left and right. and then Q. Okay, so this one can be read as P if and only if Q. Okay, or you can say P is equivalent to Q. Okay, or you can say P is necessary and sufficient for Q. If P then Q, then conversely P if and only if Q. And I usually write this P if and only if Q. Okay, PIFF Okay. This one is true only when P and Q have the same truth value, right? So if P is true, Q is true, then P if and only if Q is going to be true. Otherwise, it will be false if they have similar, if they have different truth value. Okay. Okay. Any questions so far? Okay, no questions so far. So I'm gonna take a break here and then set up a quizzes, and then we can come back to do the last part of this slide, which is rule of inference. Okay, let me just stop sharing here. Okay, and then here. Okay, yeah.นะครับมานะครับ quizzes นะครับมาจอยเข้ามาเลยนะครับ and you can join now okay okay, don't forget please name your uh, name your account and join using your first name and your student ID, okay, so that I can map back to who you are. Yeah. 15 people joined already, so still waiting. Yeah. 20 people.30 คนแล้วเราเริ่มเลยดีไหมยังมาอยู่32ยังมาอยู่นะครับ32โอเคนิ่งละเดี๋ยวนะอย่างตอนนี้มี42คน32ครับผม1ก็31ยังไม่เข้ามา9เนาะรออีก1 นาที11:05เราเริ่มกันมาเสียงแล้วใครที่เข้ามาหลังก็จอยได้นะครับยังจอยได้มาเริ่มแล้วนะครับดูที่จอตัวเองนะครับตอนตอบต บเร็วมากนะครับแสดงว่าแต่ว่าเร็วนิดนึงนะครับเพราะว่าผมเซตไว้20 วิเท่านั้นนะครับ only 20 seconds per question นะครับ okay so the question is so the question is every statement has a truth value นะครับ now basically every proposition has a truth value which is basically true ใช่ไหมครับ true เนาะนะครับ the second one โอเคครับ ก็ leaderboard ก็ยังอีกไกลนะครับยังอีกไกลนะอันนี้ the อันนี้ you can answer this by going back to the I think the second or the third slides in this lecture นะครับ just basically just saying that two simple statements or two proposition นะครับ joined by connective to form a compound disjunction นะครับอันนี้ไม่ใช่นะครับนะไม่ใช่เนาะ connective คืออะไรนะครับสไลด์อยู่ไหนสไลด์อันนี้ต้องเรียกว่า conjunction นะครับเนี่ยเรากลับไปดูในสไลด์หน้าไหนหน้าที่3นะครับเนาะหน้าที่3นะครับก็คือเชื่อมกันแบบแอนนั่นเองเนาะเป็นแอนเองนะครับนี่ก็คือ false เนาะถัดไปนะครับ a double negation is the same thing as no negation จริงไหมครับis it true or false ของ leaderboard ก็ยังไม่ขยับนะครับเอาไปคราวนี้ก็ถามว่า a double negation is the same well when you have a double negation นะครับ two negations together they basically just cancel out ใช่ไหมครับ so the same thing as no negation which is correct okayก็ in a conditional the word whenever introduce the consequence อันนี้ยากหน่อยนะครับต้องแปลดีมีอัปเดตนะครับคุณธนพลแจ้งอันนี้ เข้าใจความหมายไหมครับเนาะ conditional statement จำได้ไหมครับ if p then q right the word I should have put maybe a bracket or double quote whenever introduce the consequence we have like if p then q right so when we say whenever ใช่ไหมครับ whenever it usually means the reason right whenever it rains I will not go to school something like that so it's มันเป็นส่วนของ if เป็นส่วนของ if เพราะฉะนั้น instead consequence ก็ false นะครับ false เนาะ whenever I feel hungry I eat something same as if I am hungry I go eat something ใช่ไหมครับ whenever ถ้าข้อนี้จะให้ถูกก็คือ introduce the hypothesis or the reason okay next one In a 3-variable truth table, there are 6 rows. We just discussed this today, earlier in the lecture. Oh, okay, Let's see the leaderboard. Oh,ขยับเยอะมากนะครับ So this one is saying that if you have 3 variables, variable basically means a proposition in this case, right? Statements, 3 statements, 3 atomic propositions. So this one means 3 variable mean PQR, right? Basically. So if you have 3 variables, how many rows you should have in your truth table? Okay. So basically, I think we discussed it.
8.
8. Oh, exactly. Excellent. Excellent. We just said, we just learned earlier that the number of rows in your truth table depend on the number of variables or the number of atomic proposition in your expression, in your statement. Okay. So the number of row can be calculated by using 2 to the power of the number of variables. So in this case, it will be 2 to the power of 3, right? Basically. So this one is not 6, basically, it's 8. Okay, so there are 6 rows, that's false. Okay, so I'm a bit surprised that half of you got this one incorrectly. Okay, next question. If just one statement in the conjunction is false. Okay. Okay, let's see the leaderboard. Okay, leaderboard. Ooh, we have a new leader. Okay. So to be able to answer this one, first you have to understand what a conjunction is. Okay. If you don't remember, I suggest you go back to the slides, maybe the number 5 or number 5 or number 6 page, the 5th or 6th page. Okay, so basically conjunction is an and statement, an statement. Okay, P and Q. Okay, so it's just saying that if one of the statement in conjunction is false, so you know that usually you know that if they connected with and, if one of them is false, the other one will, well, I mean, doesn't matter what the other one is, the whole conjunction is false, right? So most of you got this correct, yes, because it said the whole conjunction is still true, which is wrong, so false. Okay, so 23. Well done, 11 of you. You probably don't know what a conjunction is, and you mix up with you don't remember if one of the conjunction is false. Maybe you misunderstood, like, oh, okay, I don't know. So now you know. Okay, if there's another question like this, don't get it wrong. Okay, the next question. Okay, time's up. Let's see the leaderboard again. Is there any change? Ooh, the leader still คุณกฤษยานะครับOoh, I had a feeling that you get this one more correctly more than last one. So this one saying that if only one of the statements in disjunction, so disjunction is an or statement, P or Q. Okay, P or Q. What happened if one of the P or Q is true? It's always true, right? P or Q, if one of P or Q is true, the whole disjunction is true. But this one is saying that the whole disjunction is false if one of the disjunction is true, which is false, right? Ooh, 15 of you got it incorrect. Okay, maybe you don't understand what a disjunction is. Okay, same. Go back to the slides. Look at the earlier page. Okay, you should see the table that explain conjunction, disjunction. You have condition. Okay, do this comment. เป็นค่าของมันหลุดแล้วเข้าไปตอบต่อไม่ได้นะครับอ๋อ that's okay ครับ okay, I hope no one else got disconnected. Okay, next question. The symbol used to indicate a conjunction is so let's see the leaderboard. Okay, still same leader. So it's true. uh it's conjunction, right? So it's this one a little bit tricky because most of you probably thought about the symbol, the V-shaped symbol. This one is also used as well, the and symbol, right? So it's also true, right? So it's and. Very tricky. The next one, we have 5 more questions. Which of the following sentences could be considered as a proposition? Okay. Don't look at my screen, okay? Look at your screen. You get, oh, this one 30 seconds per question. Okay. So that's the 9th question so far. We have a switch of the leaderboard now. Okay. So let's see. So the question is, which of these sentences could be considered as a proposition? Okay. You remember that proposition is a sentence that has true or false value, right? Basically has true value. Okay, so let's see the first one. You should study by. You should study by. I think I'm not sure if I want to put you should study by something, but it's a you should study by. So basically, it's a sentence that you tell somebody to you should study by. I don't know, by using book. The second one, I wish I will pass this. So this one doesn't have truth values to it, right? I wish I passed this. It doesn't say that I passed this. It doesn't say I don't pass this, right? I wish I passed this. Okay, it doesn't have a truth value to it. Good night. Good night. Of course, good night. It's just saying that, okay, say good night to someone. He know what he is. Okay. Interesting. So the last one, he knows what he is. Okay. So he knows the sentence doesn't say that what he is what he actually is, but he know the sentence is concentrated on he knows something, right? He knows something. So it can be true or false, right? Because if he knows what he is, actually know what he is, that become true. But if he doesn't know what he is, it become false, right? So this one is the only one that has the true values to it. Okay. The other one, no, it's just sentence that doesn't have a true value. It's getting harder. The next one, We have 5 more. This is very tricky. It's very interesting. Okay, so let's see the leaderboard. Okay, no change in the leader. Okay. Okay, it is very interesting. I'm not sure if you're confused with it or you're confused with very interesting. I don't know if maybe I change it to something like let's say like what is it in training? COVID is very interesting. Does it change into it's easier to see the proposition? This one is actually a proposition now because I think what you have to think of, it is very interesting. I mean, if you think of the content, you know, when you say it is very interesting, you're saying something, you know, like I don't know what it in that person mind that, but you have to think of like when you listen to something like that, it is very interesting. It's something that people say that okay, could mean like COVID is very interesting or this book is interesting or so it's either true, okay, it's really is interesting or it's maybe false, which is not interesting at all, right? So this one has a truth value to it. It can be, you know, for him, maybe it is really interesting for him. Okay. So this one actually, yes, maybe a bit too tricky. Next one. Okay, this one you have to type in, type in the correct answer to this to complete the sentence. Okay. What should be in that space over there, that in the sentence? There are possible ways of writing this one, so just think of the most correct way that you can write. Okay, there are a few correct ones. Okay, let's see the leaderboard again. Now we at the 11th. There is a change of the leader. Okay. So basically this one you can either, I think you can either write in false. I mean like a capital F as well would accept. I think a small f like FALSE also. But the most correct way to answer this is to write false like F capital FALSE. Okay. I don't know. Right. Okay. Right is definitely not the correct one. False is yes. That's correct. True. No. False. Yeah. False. False. True. True. No. Except. Interesting. False. Oh, this one. Sorry. Kun Priya. False name. False is not correct. I didn't. Actually, it should be correct, but I didn't put in the correct response for this one. This one will be correct, but this one will not. The small cap will be correct, but big cap will not. Sorry about that. Okay, the next question. The last three question. Either I am going to take a bath or I am going to smell funny. What is the propositional connective used in this statement? Okay, only 30 of you answer. Okay, let's see. Ooh, change of the leader again. Okay, so the sentence is saying that either I am going to take a bath or I am going to smell funny, right? Okay, so this one is actually, well, if you remember, I usually it's neither of them, right? So basically it's just saying that I am not going to take a bath and I am not going wait, either or right, either or, so it's negation of either of them, right? Negation of the either of them, right? So it's I am not going to take a bath, or I am not going to smell funny, right? So basically it's it's the negation of or, basically. Okay, that's why you can use the, well, that's the second that is answer that is already incorrect, right? It's the symbol is pointing at the opposite side, and I can see why your answer would be and, right? But because with and you don't have the negation the negation content in that one, so no propositional, no that. So it's basically it's XOR, right? The basically it's X. Remember XOR? What is that XOR? What this one XOR is that it will be true when the truth values of both of them or both of them are not the same, right? So it will be true if the first one is true and the second one is false, or the first one is false, the second one is true, right? So that's exactly the XOR. Okay, so that's one. Maybe it's too hard. Last two question. Either I am tired or I am resting, but not both. Ooh. You have to interpret this sentence now. I am too tired or I am resting, but not both. Okay, let's see the leaderboard again. The last two questions. Ooh. Okay, the leader is not okay. So this one is saying that either I am tired or I am resting, but not both, right? So either I am tired or I am resting, right? The first choice is I am tired and resting, which is definitely incorrect. The third one, I am resting while I am. I think I missed the I am tired. Sorry. I mean, I am resting while I am tired. Well, that's I well, maybe it, wait. Okay. Just the choice is missing. Okay. I should use it. I am tired and resting at the same time. Okay. This one is definitely incorrect, right? The third one, I am resting while I am tired. Well, definitely not, because this one just saying that you are doing this both of these resting and tired at the same time. Rest is for the week. This one is doesn't have anything related to this one at all. I am tired, therefore I am not resting. Okay, this one is correct, right? Because you're tired, therefore you're not resting, right? Because this sentence is saying that you just have to choose between tired or resting, right? So the second choice is the most correct one, which most of you answer correctly. Okay, well done. The last question. This one probably the easiest one. One of the easiest one. Okay, time is up. Let's see the leaderboard, the final leaderboard. Okay, no change in the leader. Let's see the question. So this one is saying that if P is true, Q is false. Okay, if P is true, Q is false. What's the truth value of the compound proposition P and Q, right? So if P is true, Q is false. The P and Q is false, right? So right is not correct, wrong is not correct, true is not correct, so it's false, right? Question. I'm not sure if you who answer right or wrong or the T, maybe I don't know. You just guess. Maybe. Okay, so this one, you should get it correct. Okay. Uh, okay, that's the end of the quiz. Okay. Thank you, everyone. Let's see who's the winner. Oh, loud sound. So the first one, Kun. Oh, too quick. Okay. So the winner for today's quiz is Kun Hong Aswin หรือเปล่านะครับ No, uh, forgive me if I read it incorrectly. The second highest score is คุณกฤษชยา and the third position is คุณพริยานะครับก็ congratulations นะครับ let's see how many questions you got it correctly. Oh, okay. No one got all correct questions, so I'm not sure if you're เป็นคนเดิมไหมครับที่ชนะเมื่อรอบที่แล้วนะคุ้นๆนะแต่ว่า I can't remember. Okay. Well done everyone. Okay, let's come back to the last part of the lecture. So okay, the final part of this slide, this part of the lecture of proposition, we're going to talk about argument. Okay, so what is argument? Argument is, if you think of the argument, the word argument is mean like we are giving reason, or we are, like discussing with someone or many people, or just another person about something, or about another topic, about some topic, and then you're trying to reason with him. Okay, reason, maybe you're just discussing some maybe sport topic. Okay, today is, I think, there's an NFL, right? The American football, NFL. So maybe you're discussing who's gonna win. Like, I'm not sure who. I don't remember who's going to the final, but maybe team A is gonna win because this and this and this, and team B is gonna win. The other person will say team B might win because of this and this. And when you're reasoning, you create this argument. Okay. So basically, when we talk about argument in our propositional system, basically argument is a sequence of a propositions. Okay, a sequence of propositions. Basically, it's just statement, a proposition after proposition. Okay, so you just basically giving each other a proposition. Like, okay, today is Monday. Because it's Monday, the team A is statistically play better on Monday. All these proposition. Remember, this proposition has to have a truth value, right? It's either true or false, right? So you can reasoning with this proposition, keep a reason and keep reason and reason and reason until you can finally come to a conclusion. Okay, so all the proposition that before the final one will be called a reason, or a premise, or an assumption or hypothesis. Okay, premise, assumption, hypothesis. So basically, these are the things that has a true value, and it must have a true truth value, a true truth value. Okay. Every statement, every proposition before the last one is called premise, or assumption, or hypothesis. The final proposition, which will be called the conclusion. Usually we use a symbol, the dot, a triangle dot, a triangle, three dots. These will normally place at the end. So you have the statements, proposition, until the last one. This one is called conclusion, and this one is called premise. Okay. Now this is argument. Argument can be two things. Argument can be valid or argument can be invalid. Okay. And valid argument means that from all your premises, if the conclusion can be drawn from all your premises, then the argument is valid. Okay. But if the conclusion cannot be concluded or cannot be drawn from your premises, then your conclusion is not valid, okay, or is invalid. Okay, that's that. So in this section, we're gonna learn how to validate or how to find whether the argument is valid or invalid. Okay, that's how we're gonna do it in this session. Um, oh, okay. So this is how we're gonna write a argument. You have premise number one, premise number two, up to premise number n. You can have all the premise. Each premise will be proposition, statement, single, or atomic or compound argument, or compound or atomic proposition. Okay, and the last one will be conclusion. Okay, this premise has to be true. Has to be true. Always have to be true. Okay, so if argument is valid, mean that the conclusion has to be that conclusion, or like from all the premise, and then the conclusion can be drawn from the premise. There are no other choice from the premise. You get the valid argument. If the conclusion is cannot be drawn or is not conclusive, then the argument is invalid. Okay, so how do we check? How do we check? Well, for example, you can look at this argument. Okay, we say that you have a statement. Let's say this one. If Iron Man is a man, okay, then Iron Man is mortal. Okay, I assume everyone knows Iron Man, right? So this one just saying that if Iron Man is a man, so basically he's not. It is in the sentence a man. It doesn't mean like he's a man, like a man and a woman, right? A man in this case, it means like he's a human, right? He's a human. Then Iron Man is mortal. Mortal mean what? Means that he can die, right? He's not gonna live forever. The opposite of mortal is what? Is immortal, right? Like you have this immortal combat game. Mortal Kombat game. Mortal Kombat game mean like you fight until one of you die. So and everyone is not is everyone in the game are mortal, right? So everyone can die from the game. So if if Iron Man is a man, then Iron Man is mortal. That's our first premise. The second premise is Iron Man is a man. Okay, Iron Man is a man. Now the conclusion is Iron Man is mortal. Iron Man is mortal. Okay, this is our argument. This is our argument. The question is this argument valid? Okay, so we have two premise, one conclusion. The question is this argument valid? Okay, valid. So the approach that we use to do this is we're gonna use a reasoning. We're just gonna keep reasoning. So basically, this one means that every premise has to be true, right? So this one true, this one true. Okay. So what we're gonna do after we assume that the premise are true, we're gonna check if the last sentence here or the conclusion here has to always be true. Okay. How can we do that? Well, if you look closely, Iron Man is a man, that's true, right? And then if Iron Man is a man, then Iron Man is mortal, that's true as well. Okay, so you can see here, Iron Man is a man. This one we know that's true. However, we also just see this Iron Man is a man is in the as hypothesis part of the if then uh, the premise on top, right? So we know this one is true, right? This one is true. This one is true because we know that from the bottom there. Now the question is, if this one is true and the whole sentence is true, can this part of the sentence be false? Because if this is false, it means that conclusion is false. But this one is true. I mean, no matter what, the conclusion has to be true, right? So we have the argument is valid. Okay. So now, can Iron Man is mortal false? No, right? Because the whole sentence is true, but the assumption is already true. So the last part cannot be false, because if true then false is false, right? But we want if P and Q is true, okay, which means that this one has to be true, has to the sentence, which means that all the conclusion has to be true as well, right? Because it's the same sentence basically, right? Which means that this statement is what is valid. Okay, maybe if we change into a symbol we can see better, like let's say that if Iron Man is a man is P. Okay, if Iron Man is a man is P, and then Iron Man is mortal is Q. Iron Man is mortal is Q. So from the argument we can change to symbol using if P then Q. So which means if Iron Man is a man, then Iron Man is mortal, and then Iron Man is a man, that one is P, and then Iron Man is mortal. So as you can see that if P is true, Q cannot be false, because P if E then Q is true, so this one has to be true, which means that Q is true, which means that our conclusion is true, which means that the argument is valid. Okay, the argument is valid. Any question so far? Nope. Okay. So now that's just a simple example how to validate argument. Now there are two ways you can do to validate the argument. The first one is using truth table. So we're gonna go back to truth table, and then we're gonna use truth table to validate the argument. The second one is to use the rule of inference. เดี๋ยวผมขออนุญาต2 นาทีแป๊บ มาต่อนะครับเดี๋ยวเราดูกันเรื่อง truth table ก่อนเนาะ so in order to validate the argument using truth table basically step that you have to do is first you have to identify what's the premises and what's the conclusion from the argument that you've given. Okay, the second step is to construct a truth table showing the truth values of all the premises and the conclusion. Okay? And the last step is to consider the what we call a critical row. A critical row is a row that all the premises have a truth values as true, and then you check on all that critical rows if the conclusion have the truth values as true. If there's one single row, at least one single row that have the truth values for the conclusion in the critical row as false, then the argument is invalid. But if all the critical row, if all the truth values of the conclusion in the critical rows are all true, then the argument is valid. Okay, so let's see example. You see that example 7, you want to validate the argument where premises are P or Q or R and negation or that's the conclusion, and then that's the premises, and the conclusion is P or Q. Okay, so before you creating a truth table, you can see that there are 3 atomic position P, Q, R. So I put the atomic position here P, Q, R, and then I put in the conclusion here at the final column, and then this one and this one are the premises, right? So I write because there are 3 atomic propositions, so my table will have 8 rows. Okay, so I listing P, Q, R as shown here, and then I list all the truth values of each expressions P or Q or R, and then negation or, and then P or Q. Okay, and then I check for the critical row. So critical row will be the row that all the truth values of the premises are true. So you have this row, and this row, right? Not first row, because that one is true, that one's false, true, false, true, false. So basically row number 2, row number 4, row number 6, right? So in these 3 rows, you have to go check the conclusion, truth values of the conclusion of the row 2, 4, 6. And you can see that all the truth values in the row 2, 4, 6 are all true, which means that this argument is valid. Let's see another example. Similarly, if you have a premises of P or Q or R, and then the negation or same premises, and the conclusion is P imply Q and negation or. So again, create a truth table. Okay, this is atomic proposition P, Q, R, and this is the premise P or Q or R and negation or, and this is conclusion. Okay, so after fill in all the truth table, all the truth values in the truth table, you look for critical row, right? And this one critical row would be row number 2, row number 4, and row number 6 again. Okay, in these 3 rows, you have to check the truth values of the conclusion. As you can see that the first one is true, the second one is false, and the third one is true. So this one, since the conclusion, the truth values of the conclusion are not true, then this one is invalid. The argument is invalid. Okay, that's how you use the truth table to check to validate the argument. Okay. I don't know. Okay, I'm just gonna start it a bit, and then maybe we can stop. Okay, the second method that you can use to check to validate the argument is to use rules of inference. Okay, rule of inference. The reason we want to use rule of inference is because sometimes truth table just not enough, right? As you can see that the truth table will, the number of truth table, the number of row of the truth table will be according to the number of atomic proposition n. So you have 2 to the power of n rows if you have two table, and n is the number of atomic proposition. However, sometimes if n is like n is 3, it's okay, but n is 4, you get 16 rows table, which is quite a lot. You have n5, you have 32 rows. That's a lot. Okay, maybe it's not very efficient to validate argument using that. So the other way is to use rules inference. Rule inference is basically saying that you use what you already know is true, and then you try to use premises and whatever rules that you know that are already true to kind of come to conclusion that the conclusion is true or the conclusion can also be false. If you can come, you can draw on, or you can approach, you can convert all the with the premises and the rule and the statements that you already know are true, and then you can conclude that the conclusion is also true, must be true, then your argument is valid. But if you cannot conclude that the conclusion should be can be true, can sometimes be false, then the argument is not valid. Okay. For example, if you have remember the Iron Man example. Let's say if you have P imply Q, right? This one is premise, right? And then because you know that if P is true, if P is true, and then Q cannot be false, right? Because Q has to be true. So from these premises, you know that Q must be true, which means that this argument is valid. Okay, it's valid. And these are the list of all the inference that they already proved already true. Okay, for example, addition. So if you know that P is already true, you can have that. You can also conclude that P or any Q, any proposition Q, will also be true. If P and Q is true, then you can conclude that P must be true, right? If you have P and P imply Q is true, then this one is called modus ponens. Q has to be true, right? Modus tollens is saying that negation of Q is true, P imply Q is true, negation of P is true, right? Hypothetical syllogism: if P is Q, if P then Q is true, Q imply R is true, then P imply R must be true. Disjunctive syllogism is P or Q, negation of Q, then you get P, right? And the last one is dilemma proved by division into cases. P or Q, P imply R, Q imply R, then you get R. Okay, these are the rules of inference that you can use to try to get to the conclusion. Okay, make sure that you write the name of the rules that you use when you use it. Okay, and again, you don't have to remember all this. You can always come back and look at the slides and then use it. I think I'm going to stop it. I don't want to start this one because I'm not going to be able to finish it. Okay. So today we discussed about a lot more on the logically equivalence and truth table. Okay. We've seen a lot of useful logical equivalence. Okay. And then we talk about tautology and contradiction. We talk about conditional statement and biconditional statement. Talk about the rules of inference a little bit, and then we see that what is argument and how can we validate argument. Well, at least by one method using truth table. Okay. So I'm just gonna stop here. Do you have any question? Ooh, thank you. นะครับ if we don't if อาจารย์แค่อยากสอบถามว่าค่าอาจารย์จะมีจัดสรรให้บิดออนไลน์ใช่ไหมครับเป็นคำถามที่ดีนะครับออนไซต์ตอนนี้คณะเหมือนให้ได้แล้วนะครับ ถ้านักศึกษาออนไซต์ไม่ถึง50 คนนะเราอยากออนไซต์กันบ้างไหมนะคือถ้าออนไซต์มันก็จะได้จริงๆมันดีนะผมก็ได้เห็นレスปอนส์ฟังรู้เรื่องไม่รู้ เดี๋ยวเราอยากจะออนไซต์เดี๋ยวเราลองออนไซต์ดูดีไหมสักครั้งสมมติอาทิตย์หนึ่งเราอาจจะออนไลน์สักวันแล้วก็ออนไซต์ผสมสักวันหนึ่งเนาะนี่นะครับเนาะเผื่อจะเปลี่ยนบรรยากาศบ้างเนาะออนไลน์บางทีก็โอเคนะครับเดี๋ยวผมแจ้งรายละเอียดทีนึงออนไลน์ผสมออนไซต์เริ่มอาทิตย์หน้าดีกว่าเนาะเริ่มอาทิตย์หน้าวันจันทร์อย่างนะวันจันทร์ผมจะสะดวกออนไซต์วันไม่เป็นไรเอาเราเป็นหลักเอาเราเป็นหลักโอเคเดี๋ยวเราอาจจะวันจันทร์ถ้าอย่างนั้นเนาะวันจันทร์ออนไซต์วันจันทร์วันหน้าแล้วก็ออนไลน์วันพุธโอเคนะครับมีคำถามถ้าไม่มีคำถามเพิ่มเติมวันนี้ก็เท่านี้นะครับเดี๋ยวเจอกันวันพุธยังออนไลน์อยู่เนาะเดี๋ยวให้